in the last 10 years and are basically new on the scene, and to do so in the context of the markets and the technologies, and to update the international roadmap that was put together by the first study group and presented to the Academy in 2011. Second, because of the tremendous impact that space solar power could have on humanity's future in space, to basically examine and assess those opportunities. If you'll remember 2008, it was the end of the Bush administration. Let's see, if I think it was 2009, based on the schedules of that time frame, maybe it was 2010, when SLS first flew. That was a joke. If you go back to the 2008 schedules and planning, the SLS was going to be flying within a couple of years. By the time we completed the study, obviously all of that had slid off comfortably to the right and continues to slide, unfortunately. The moon vanished. The vision for space exploration vanished. We're going to Mars, and then we're going to an asteroid, and then we're bringing back a piece of an asteroid, and then we're bringing back a rock. So the last 10 years have been very chaotic and disappointing with regard to space exploration and the development of space. However, if you look at the prospects as of today, half a dozen countries, Japan, India, China, small companies are all going to the moon. Luxembourg has a $200 million investment fund for new space resources. The U.S. is now focused on the moon again, the moon and Mars, and doing it with commercial partnerships. It's a radically different picture. And all of that will require energy, as we were talking about this morning. And it'll require vast amounts of affordable energy for anything like the visionary things that are being talked about to be realized. And so that warrants attention. And because of these things, and the new space sector in particular, the study will be looking at the potential role that extraterrestrial resources might play. And this is not a simple substitution role, in that if you're going to make something out of terrestrial materials that have to be lifted out of the Earth's gravity well, mass would be at a premium as well as manufactured cost. Whereas if you had the opportunity to make pieces of a solar power satellite out of lunar regolith-derived materials, where you have the prospect for electromagnetic launch, or out of asteroidal materials from small bodies where energy transfer requirements are quite low, it might be sensible to make pieces of a solar power satellite out of different materials choices than you would if you had to lift the materials out of the Earth's gravity well. So, and as you can imagine, these relationships between the systems concepts and the technologies involved, how they might play into the markets, looking at the potential applications of these to extraterrestrial missions and markets, and looking at how extraterrestrial resources might play into those, all of that is an interrelated question. It's not a single, not a set of single questions that will be looked at independently, but a problem to be addressed and synthesized by an integrated activity. The intermediate goals, obviously identifying the markets and the applications for energy, identification of the technical options, looking at how for global energy needs as well as for government and commercial space mission concepts and markets, evaluation of the impact of these emerging transportation system options on space solar power, particularly those that are coming along in the coming few years, identification of and evaluation of the options for extraterrestrial materials, and evaluation of SSP architecture level figures of merit towards the goals that would be necessary to have economically viable space solar power for space applications or for terrestrial markets. I think some of these considerations are related to the ones that, for example, Paul Jaffe has been looking at with regard to the figures of merit that would allow you to evaluate the goodness of different accomplishments in space solar power and generally, but wireless power transmission specifically. And lastly, identification of other issues and policy questions. Particular attention on spectrum allocation, topic we spent the morning on, or the latter part of the morning. Assessment of technical feasibility and maturity and the degrees of difficulty for various systems concepts. Trying to put together one or more roadmaps for how this could be accomplished. It is to the point of the roadmap. I will give you my biases. My biases are that a system that is optimized for power out in the main belt asteroids, and a completely different system that is optimized for power to Mars, and a completely different system that is optimized for power to the moon, and a completely different system that is optimized for power in Earth orbit, and a completely different, that if all these things are unrelated to one another and are completely different, you might get a better engineering solution for each of these, but you won't get a better global solution. You won't get one that leads to greater progress over the coming decades. And so I think putting together this roadmap is something that requires looking at the total picture, not at each problem as a separate engineering thing to be optimized. And then, of course, the development of the report. So, the primary new topics, which we've talked about already, are these top 5. Examination of the specific new system concepts, examination of the markets and missions, and attention to critical regulatory issues, in particular spectrum. This is the draft work breakdown structure. My background is in project management, and I believe that a good work breakdown structure is your friend, and a bad work breakdown structure is your worst enemy. So organizing things in a clear fashion, I think, makes sense. And you will not be surprised to discover that these major elements in the work breakdown structure look a lot like the objectives of the study. So form follows function. So it includes looking at the system concepts, looking at supporting systems, including launch, and so on. In terms of the missions and markets, looking out over several decades, there was a very nice set of activities undertaken by Shell Oil in the 1960s, having to do with scenario-based planning, thinking about what the future might be like. I don't know how many of you have spent any time working for a government agency in whatever country, but one of the things government agencies know is the future. You can just ask them. They all know exactly what the future is going to be like. It's going to be what is in their current plans and budgets. And when suddenly the future changes, there's an election, there's a breakthrough by somebody else, or there's a threat, or who knows. They change when they need to, and then they have a completely new direction, and they're just as certain about it, the new direction. Well, in the 1960s, Shell Oil, the only one among the majors, said, what if, and Peter Schwartz was one of the people working with Pierre Wack, said, what if there's a conflict in the Middle East? What would that do to the cost of oil? Was one of their scenarios. And they were the only ones who were ready to exploit the market impact of a conflict in the Middle East in 1968, 1973. So I believe in scenario-based planning. For the first study, we looked at 4 scenarios 10 years ago, and the 4 scenarios were business as usual turns out to be fine, i.e. we don't need to do anything special, we just go ahead the way we are. And remember also, I should have put up another, it's not directly related to this study, but it's related to the energy market. This is before fracking. So 2008 to 2011 was before fracking. And so the gas was going up, oil was going up. It was on the order, 2008 was the year the Great Recession started. That's when we did the last study. And the price of oil was like $110, $120 a barrel, all before hydraulic fracturing. But so that was, suppose that the business as usual works out. That was one scenario. Another one was we continue as business as usual, and all of the climate change impacts are at the high end of the predictions. I don't know if you know the story of the frog. You put a frog in a pot of boiling water and he'll hop out and escape. You put a frog into a pan of cool water and you bring the temperature up very slowly and you have frog soup. But this is the story. I would assume any frog worth his salt would in fact leap from the pan the moment it starts to get uncomfortable. Nevertheless, it makes a good story. Anyway, it was the basis of the scenario. Also, if you've got decently boiling water, you're going to kill the frog the minute you drop it in. So, but setting that aside,
there's still frogs to be kissed.
There's still frogs to be kissed. That's so true. So true. Gamma was, what if Peter Glaser was right and fossil fuels run out, and they do so within the foreseeable future? Then there were time frames associated with this. And lastly, what if we pursue green policies and those work out? So there were one scenario that was bad and three scenarios that were basically good for humanity. There's basically an optimistic set of scenarios. So we will again be looking at scenarios for the future, but update those based on current circumstances. Whether it'll be 4, I can't say, but 4 is a nice number because if you put the 4 together, it makes a 3-dimensional tetrahedron.
Is there any significance to that picture other than the fact that it makes a pretty tetrahedron?
Only because it suggests that there are relationships between alpha, gamma, and beta, between gamma, delta, and beta, and so on. That the ones at the corners have relationships with the ones that make up a side.
And in what sense is scenario gamma a good one? You listed it among the good options.
Oh, actually, no, it's a terrible one. You get economic collapse. I apologize. So beta and gamma were bad. Alpha and delta were good. I apologize. You're quite right. Yeah, the fossil fuels running out, the way the scenario forecast worked out, it was extremely bad because the cost of energy went up from $120 a barrel, and it went up quickly enough that there was no time to do anything about it. So it was actually a very, very bad scenario. Your point is well taken. I guess it was good for the Earth, but pretty rotten for humanity. This diagram, which Paul has seen recently, came out of the Academy study. And this is intended to be a completely generic system block diagram, functional block diagram of a solar power satellite system. It may not be entirely correct. Some things obviously don't happen. For example, some systems don't have optical front ends, like the reference system did not. It had a planar silicon-based PV array. And some systems don't have gimbaling systems per se between the power management and the WPT. There's no gimbaling system. So, but if you have the options, you can either add them or not add them. All of the SPS systems have some kind of in-space assembly or deployment. All of them have launch systems. All of them have ground receivers and so on. And this also is something that could be updated based on new system concepts that have come along. Probably the one big thing that I've personally been adding in looking at space solar power more recently is the addition on the ground system of energy storage, limited energy storage systems. And that's to compensate as a minimum for the vernal and autumnal equinoxes the time when the sun is not shining on the platform, to put an energy storage system, modest energy storage system on the ground. And that would also allow you the opportunity to periodically turn off the system if you needed to without having a power interruption to the customers. So this one would be will be updated with the addition of energy storage as a minimum. Please.
What is for the gimbaling system?
My wrist is a gimbling system. It's a pointing system.
For the pointing.
Yeah, for the pointing of a piece of the platform. For example, in the reference system, the solar arrays pointed constantly to the sun, and there was a gimbal to allow the PV to point at the Earth. That's a gimbling system. And this is the overall study approach. So identification of the scenarios, identification of the figures of merit, do a preliminary analysis and identification of the trade space. Another workshop, date and location to be determined, but probably a couple of years from now. This is, after all, this is May. The study was approved and started in March. So it's been underway now for 2 months, the end of March. A series of focus studies to be done, and then the various pieces of what will be the final report. In terms of execution, this is the approximate plan. Study started in March. This is the kickoff workshop today, this afternoon. And then a series of working meetings taking advantage of future ISDCs. Tentatively, another significant workshop 2 years from now at the 2020 ISDC, but that's to be determined. And complete the study 3 years from its start in March of 2021. I wanted to offer one technical highlight on a piece of the new study activity having to do with space applications. So this, of course, is the ambient light on Mars from the Opportunity rover. And as you can see, during the dust storm, the amount of available light plummeted. We had some conversation earlier about the idea of Elon Musk of putting a city on Mars with 1 million people, of Dubai's idea of a city on Mars by 2117, with many thousands of people on Mars. I don't know that they've said 1 million. Those people are all going to require a lot of energy, and clearly, ground-based solar is not going to cut it when you can have months of essentially minimal sunlight on the ground. However, you can conveniently put a solar power satellite. I've just happened to use one that I'm familiar with in an aerosynchronous orbit around Mars and deliver power wirelessly to either a large outpost or to locations scattered around that face of the planet. A couple of different options. You could put it in aerosynchronous orbit at about 17,000 kilometers. Another, you could put it in a polar orbit, analogous to a sun-synchronous orbit around Mars, and deliver power globally several times a day for exploration activities distributed around the planet. Sir?
Are sun-synchronous orbits possible on Mars? Is there sufficient ablateness?
As long as you have adequate power for propulsion, all things are possible.
I'm propelling.
I did a calculation of that. Not only is it possible, but the relationship between altitude and inclination necessary to achieve it is very similar to the Earth by a strange coincidence.
Okay, cool. Okay, so yes.
John, you're much more concise.
Yes.
My sensing time is not great.
Okay. And in that case, you've got a Mars architecture, a few hundred kilometers up, maybe, 589 watts at Mars orbit. You could use microwave to millimeter wave to transmit the power, for example. You get occasional eclipses of the platform. If you are going to deliver a reasonable amount of power, say a kilowatt per square meter for a few minutes per day, then you have surface-based batteries. And you have a food chain from incoming sunlight to outgoing DC power, which very closely resembles the energy chain, end-to-end energy chain for terrestrial applications. So that's just as an example. So there are lots of other ones to be looked at. The moon, for example, near-Earth asteroids, frankly, main belt asteroids are perfectly tractable, etc. This is the current study team. I think Tanaka-sensei went to bed because he got in this morning. But I'm currently the chair. I'm trying to line up two co-chairs. Harun Okab is the secretary. We have a series of several current members, several others who have been invited, but we're waiting to hear back. And I'm offering an open invitation to folks who are here from the community today to become part of the study group. Conversation.
Can you reduce the effects of beating down energy by doing it to remote places? Like why not the Southwest Pacific instead of just outside Phoenix?
So the biggest dilemma if you transmit power down to where you don't need it is converting, taking the power, doing energy conversion, putting it into a form that you could then conveniently move and taking it to where you do need it. That certainly is not an implausible thing to think about, but you'd need some function in that location. And I will just say, I'm not quite ready to present it today, but I've got an idea that I'm working on with a colleague for a way to have a large receiver in the South Pacific, and I've thought of something to do with it. It is basically to use the system, and again, there's some work to be done before I would be willing to present it, but general idea, if you could deliver power reliably to a movable object in the Pacific, you could use, with lots of power, you could take care of the plastic problem.
Yeah, the plastic problem.
You could take care of the plastic problem. And that's a problem of global scope.
And you might create fuel.
And in principle, you could recycle the plastic, turn it back into fuel, turn it into construction materials, all manner of things. But you're basically converting the plastic into cash. But anyway, so it's a good idea. But but in this case, you'd use it there locally as opposed to moving it someplace else.
John, I was just wondering, when you were going through the list of the various advances that have been made that would reduce the overall system cost, given that total, what fraction of that reduction in cost would you attribute to automation and robotics in terms of replacing astronaut hours for assembly?
So we've been at the point since the Fresh Look study, so since 20 years ago, of being able to essentially eliminate all of the massive in-space infrastructure that was required for the reference system concepts. So the factories and the thousands of robots and hundreds of astronauts and all of that. Robotics have been at the point where we can argue that you can get rid of those things. System concepts like the Sun Tower, for example. The dilemma with those was that the level of robotics really doesn't allow you to go to very small modules. You've got dozens or hundreds of big modules as opposed to thousands or tens of thousands of small modules. And these days, your robotics is at the level of getting rid of allowing module sizes to become very, very small, which takes you towards larger scale mass production. And the advantage there is not, it reduces cost, but the robotics reduces cost by virtue of allowing larger scale mass production rather than the elimination of costly infrastructures. They're related, but we've been confident since '97 that the level of robotics were going to allow us to just get rid of the enormous factories that show up in the concepts of the DOE studies of the late 1970s.
And how significant a savings is that with respect to the total system?
So we got, well, in the 1990s, we thought we had gotten from the cost of first power for the reference system concept was on the order of $1 trillion. By the late 1990s, we thought we had gotten to the point where the cost of first power was about 50 billion, so about a factor of 20. By simply getting rid of all of that upfront investment. So, and now it's even better.
In addition to your concept of Pacific Ocean plastic recycling, I'd recommend considering humanity's predilection for wasting resources, that you consider using space tourism or entertainment as catalyst for
Yeah.
space solar power.
Yeah. John?
Yeah, for the Mars application, since there's nothing alive on the surface of Mars, and since there's all
That's an assumption.
atmosphere-
That's an assumption.
Yeah, but with the UV flux and the low humidity and the cold temperature.
It's a pretty reasonable one.
Yeah, pretty reasonable. I don't, not discounting at all, there could be stuff under the surface, but
Right.
on the surface, chances are extremely low. So, I mean, they use UV in hospitals to get rid of bacteria, you know, come on. So, the logic.
None of them have eyeballs
Yeah.
yet.
So the logic here is then, with a much thinner atmosphere, we don't know what kind of an ionosphere it might have for bouncing radio beams around, probably not. That you could probably have much higher power levels per square meter to the ground than you can have on Earth. We have this, I think it's 1/4 of the power of sunlight, or roughly 250 watts per square meter, is the approximate power level that comes into the typical antenna. So suppose you could do, you know, equivalent to the Earth, 1,000 watts, could you do 2,000 watts? In other words, something that won't physically damage something in the ground, but you don't have to worry about living things in or under or near the antenna. So you can make your antenna much smaller, and it's easier to assemble on the ground and so forth.
No, it perfectly legitimate point, and that's the reason why these numbers are run for about 1,000 watts per square meter, as opposed to the upper limit for the.
Okay, 1,000 watts.
But it's just pulled out of the air. I mean, there's a need for study. I think that the number one thing you'd want to avoid is inducing electrostatic discharges.
Right.
You don't want to induce discharges that are going to fry your electronics. The thing you're trying to send power down to, if it's not shielded properly, you could induce voltages. You ever put a gold rimmed cup in the microwave oven? You get voltage buildups on slightly discontinuous pieces of metal fairly quickly, and they go. Pfft.
Because the surface pressure on Mars is almost ideal for neon tube type electrostatic discharge glows.
So, but so anyway, the answer is absolutely yes. In the 1990s, in the Fresh Look study, one of the things that Harvey Feingold looked at was what could we do for Mars, and he concluded that numbers of about up to 245 gigahertz would work fine, because the dust particles on Mars have about the same diameter as smoke, which is why they say airborne in air that's so thin, and that was estimated. He estimated that this would be approximately transparent to 245 gigahertz. You can't go to optical because you've got dust storms that would absorb the visible light transmission, but up to short millimeter wave, terahertz. I think that's terahertz. And no thunderstorms.
There's almost no water vapor in the atmosphere.
No.
It's all frozen out.
Right. So anyway, but to be studied, but you still have to worry about efficiencies. And for a lot of applications, you can go to high frequency and a small aperture on the ground, but if your efficiency is bad, you're still going to have to worry about your waste heat because you're in a vacuum.
And you don't want to damage the Rectangular
No.
equipment itself.
Right. So
With the refocus back to the moon, would you guys have any other such like architecture systems for maybe power beaming to the moon, or even interplanetary for like satellite stuff?
yeah, so that is entirely what is intended here, i.e., human and robotic space exploration. I don't say the moon, but this was drafted before the U.S. Announcement.
Yeah, I just think like.
But the intention is absolutely to look at.
Atmosphere.
You bet. And that would include, for example, things like point-to-point on the lunar surface, like the peak of eternal light down into the crater of vast riches. Where did the books end up?
Oh, right here.
Oh, did you get both of them?
Two.
Okay, good. Give them back.
So on the moon, you got the opposite problem. Your equipment has to be able to operate safely at 40 Kelvin, roughly.
Yeah.
So it's the complete opposite.
But you have to But if you're not on the if you're not on the poles in the shadowed regions, you don't have to operate at 40 Kelvin indefinitely.
No, but the
Temperature cycle.
areas of interest for
Are very chilly.
ice
Yeah.
are about 40 Kelvin.
No, very
There's,
true.
You know, there's even
So-
mercury atoms mixed in with it.
And so may I ask? So as a general matter of my self-interest, is anybody interested in participating in the study? Okay, it's a very good response. Thank you.
Should I ask a question about
Yes.
participation? What is required to participate in this study? So is this going to be something where I'm at home and can work off my computer, or is this something where I'm going to have to physically get together with
Only if I'm offering barbecue. Only if I'm offering. No. Only if I'm offering barbecue. So I will mention that the plan is that most of the work will be done online. However, but again, integration is necessary, and some face-to-face time is important. So some of the meetings will take place at the IACs, like this upcoming event in Bremen this fall, and others will take place at future ISDCs. So 19, 20, and 21. And of course, the IAC next year is in Washington, D.C. So it's also in the U.S. So there will be events in various locations around the world where some people can participate and others won't, and it'll alternate around. And the result is intended to be a book like the one that you've had a look at here.
Is that what the star on?
That's what that is. That's what that's intended to designate.
Okay, so please see me after this session and put a star by your name to be sure to be
Included.
counted along with everyone else in the study participation effort.
And I'm not at all above a blatant bribe. So if you're willing to be a participant in the study, and you so designate, up to the limit of the box that I brought with me, you get a copy of the report from the first study, the one that you've looked at.
And I can say it's a good book.
It was a lot of fun. It was a lot of fun. I'm hoping this one goes as well. And I will say that if you want to get a copy of it, just to show you the magnitude of my bribe, if you try to buy a copy from the International Academy of Astronautics Secretariat in Paris, they will stick you for 100 euros. So I'd rather give it away than have them. I was supposed to give them all to them, but they didn't pay for anything. I mean, anyway. And this is kind of a first come, first served thing. But if you don't get one at this meeting, and if you want to give me your business card, I will and you're going to be on the study group, I will gladly mail you one. You don't have to get your bribe today or this week, or not at all. So, any other questions about how all of this works out? What happened the last time was that the group would engage on these various topics. Sorry. Come on. The group would engage on the various topics, and different people would go off. For example, Seth mentioned his analysis for Mars orbits recently. So a part of the architecture might be, in the system concepts, would be various orbits. And we'd say, okay, well, here's what we're trying to look at for these different system concepts. How about you do a paper for next year's ISDC or next year's IAC on this topic? And then different people do papers for an upcoming event. The nice thing about, if you know what you're doing, you have a good schedule, and you have a good set of work packages, and you have 3 years in which to do it. Nobody's so burdened. It's pro bono work. Nobody's getting any money. You just get satisfaction and attribution. Okay. So, any other questions or discussion?
Point out that this book is not the same as your personal book.
That's true.
On power satellites, because some people may have seen it and thought that was a book you wrote specifically.
No.
But that's the report.
This is the report. My book references the report,
Right.
but actually came out 3 years later.
Right. Just to clarify things.
Although I want to be clear about that too. I didn't get a nickel from that either. Amazon.com, and Jeff Bezos made all the money on that. Yeah, 70 cents on the dollar.
But that means you got 30 cents on the dollar.
No, my publisher did. I was supposed to get my share after they cleared their costs.
So he's coming.
Sounds like Hollywood.
Yeah, exactly. Next time when I'm doing my second edition on the book, I'm going to self-publish. Anyway, so I don't really have a lot more on this topic, and I think it's getting late in the day on this first day. I will just mention that I will just ask first. So we've talked a little bit about the new missions and markets, especially for the moon in particular, which was asked about. New system concepts, including things like Cassiopeia. Things like the new reflector array concept from China, or the crazy one from China, SPS Omega. I don't mean that literally crazy. I'm just unfortunately he couldn't get his visa in time. He was going to be here. He's not here tomorrow, by the way, Gary. Wang. Okay. So we'll fill that time. But it's been a very rich 10 years in terms of new SPS systems concepts, which is very exciting. We've talked about spectrum. That's a different topic, so we've talked that one thoroughly today. Anybody have any concerns about the process and how this will get done? So it'd be the first part of the effort will be to identify the concepts and identify markets and put together the new scenarios and circulate them for review and comment, and then nail them down, and then so on over the next 3 years. Seth first, and then.
Just to clarify, I'm going to ask a question, and then, if you don't mind, take a stab at answering it. Do you foresee committees or subcommittees? I'm guessing no, not at this point. The group is small and cohesive, and that will just emerge.
Yeah, you are correct. And also with the paper-based approach, because we can access, for example, we could have papers in the space transportation track here at the ISDC, or we could have papers in the space power symposium at the IAC, and it's not as critical if there's a good way to bring in the individual work and have it looked at by everybody. And so, please.
I didn't know if the regulatory issue was going to be expanded out on as well? And if so, is there like partnering organizations that you would want to view input in this?
So we're going to, the answer is yes, in terms of the, but especially focusing on spectrum. But we do not as yet have any candidate organizations with whom we might work on that. But it's,
Do you think the space
there it is.
would be interested in taking something like this?
Say it again, please.
Because it's more geopolitical, do you think like the new space council?
I don't think so. I mean, I think the U.S. National Space Council is a creature of the White House and is trying to bring all of the re-chartered pieces of the U.S. government together. I don't think that they would have a particular activity related to this. I mean, I could bring it up with Scott, but I don't like asking questions where I'm not going to like the answer. So, Dave first.
Yeah, on your chart on the work breakdown structure, it said to be updated. I wonder if you had any things in mind on what you were going to change and how firm you are on keeping this structure versus changing
Well,
it from the
well, so it'll be approximately like this, but as I was mentioning previously, one thing that I know I want to add to the functional breakdown is energy storage. So there's some details in here, like this has got the wireless power transmission, power generation, power and thermal. There is no energy storage.
How will this segue into the development of a possible consortium?
So there are two topics that we talked about. Well, one topic we talked about this morning, and then there's another one that you might mean. One is a consortium having to do with advocacy, organization advocacy related to spectrum. The other would be some kind of a consortium related to the implementation of a solar power satellite. Which one do you mean?
Maybe both.
Well,
They're-
right.
But this would be a perfect group to maybe include something here on that chart.
Yeah, not the, it's relevant to the discussion for spectrum, because that's a regulatory matter and one in which all organizations have a role. However, I would just mention that the International Academy of Astronautics is a Paris-based, UN-recognized non-governmental organization, and is not, it's an honor society. It doesn't do hardware. So I think things could come out of the groups and the meetings and all of that lead to stuff, but the IAA as an entity hopes to influence the course of future events, not build stuff. John?
I presume probably one of those boxes covers the area that I want to mention. But we still have to keep reminding the people who may be interested in this report why we need space solar power in the first place. And so one of those includes continuing comparison of space solar power to the ground solar power that exists in the next 3 years, let's say in the next 10 years, in terms of how much it costs, how much land it covers, et cetera, et cetera, et cetera. So that, which box was going to cover that in that overall flow chart?
Right.
So that there's a box that's assigned to that area.
Market assessments.
Oh, okay.
Markets
Okay,
include the
I spot it.
competitors.
Okay, I see it.
But your point is well taken. It was not explicitly stated.
Yeah.
So if you will please nag me, and a similar request if you have issues that you've raised or that you'd like to raise afterwards, if you'd like to identify them in an email, then I will gladly incorporate them into the next